Okay, let's tackle this video question. We have a reaction here and we want to figure out whether the reaction is endothermic or exothermic. And the other thing we want to do is calculate the energy involved in the reaction. So by figuring out what the change in enthalpy or the energy involved in this reaction, by calculating that and figuring out whether it's positive or negative, we should be able to tell whether it's endothermic or exothermic. So given that we have a table of average bond enthalpies, we're going to go with drawing the Lewis structures for the reactants and products and discovering whether the enthalpy of reaction is positive or negative by taking the enthalpy of the bonds broken and subtracting the enthalpy, basically the sum of the enthalpy of the bonds formed. So let's go ahead and draw Lewis structures for this. We've got a carbon with two hydrogen, a chlorine, and a chlorine. So a tetrahedral structure there. It's reacting with bromine gas. So bromine single bonded to a bromine. And we are producing carbon, again with the two hydrogen. And this time we've got bromine attached to the carbon instead of the chlorine. And our chlorine gas is the other product. So let's go ahead and set up and compare bonds broken to bonds formed. Cannot draw a straight line. All right, here we go. Bonds formed. Okay, so let's change colors here. We've got two carbon-hydrogen bonds. We've got two carbon-chlorine bonds and one bromine single bonded to a bromine. On the product side, we've got, again, two carbon-hydrogen bonds. We've got two carbon-bromine and a chlorine, single bonded to a chlorine. All right, so we're going to go over to our bond enthalpies. Maybe let's make this a little bit smaller, see if we can use that. So let's look for these. We've got carbon-hydrogen here. Let's see, we've got a carbon-chlorine here, carbon-bromine right underneath that. And let's see, we have a bromine, and a chlorine. So I think that's all of the bonds that we have there. So fun fact, we have in here carbon and hydrogen bond right here that actually didn't break and didn't form. It didn't change. So we can actually take those two bonds right out of this calculation and kind of cut down on some of the math that we have to do. So we're going to go ahead and take 2 times the bond enthalpy of our carbon-chlorine bond. Looks like 328. And that's in kilojoules. And then our bromine bond, let's see, is 193 kilojoules. All right, so we look those up. We're going to add them together. Hopefully it comes out to be 849 kilojoules. And the units on there are kilojoules per mole. So I'm going to go ahead and leave it with kilojoules per mole there. Carbon-bromine bond, it looks like 276. And we've got 2 of those that we're forming. So 276. And then the chlorine-chlorine bond is 242. And we've got 1 of those, 242. Oops, and these are kilojoules of energy. Okay, so that's how much energy it would take to break those bonds. We're subtracting bonds formed, so that way we can look for the difference between the two. When we calculate that out, let's see, do I have all the right numbers? I think we get 794 kilojoules. Okay. So to find the change in enthalpy of the reaction, we're going to take the bonds, the energy that it takes to break the bonds, and we're going to subtract the energy that it takes to form the bonds. So in other words, when we do that, we end up with a positive 55 kilojoules as our difference, and that's per mole. And because we have a positive sign there, that tells us that our reaction is going to be endothermic.